Hello, everyone. Welcome. Thanks for joining us today. My name is Danica. I am with 3C Ren from the County of San Luis Obispo, and welcome to the last topic on the Energy Code Implementation Series. And this one is on multifamily buildings with instructors Jennifer Rennick and Grant Murphy from Inbound Screen Consulting. Next slide, please. And before I pass things off to Jennifer, I just have a few logistical slides to go over. A few quick Zoom reminders before we get started. Please make sure you're on mute throughout the duration of the training. We highly encourage questions, and if any questions do come up, feel free to put them in the chat, or you can raise your hand and we can unmute you. This session is being recorded, which will be shared with you along with the slides in the next few days. And just a little bit about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C Ren is funded by ratepayer dollars collected through the public goods charge found on our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we are able to bring those dollars back into our region. Next slide, please. So 3C Rent currently offers 6 programs focused around 3 services: incentives, training, and technical assistance. Our training today is part of the Energy Code Connect program, and you can find additional trainings and learn more about our other services by visiting our website, 3c-ren.org. And with that, I'll pass things along to Jennifer to get the course started.
Everybody, and welcome. I'm Jennifer Rennick. I'm a licensed architect and a certified energy analyst through KBEC. And I'm here with Grant, who's also part of the Inbound Screen Consulting team. But we're wearing our code coach hat, code trainer hat for 3C Ren, Tri-County Regional Energy Network. And like Danica said, this is the last in our energy code implementation multifamily with the update on the 2025 code. And for those of you who need learning units, 1.5 AIA learning units are available, and the 0.15 ICC units are available. Let's see. Before I dive into the agenda, Grant, do you want to introduce yourself? And also, let's remind folks that they can put their questions in the chat and introduce who they are so we understand if they're mostly architects, engineers.
Yeah, my name is Grant Murphy. I'm with Imbalance as well. CEA, I do commissioning, help with all the Title 24 lead, other stuff. As Jennifer mentioned, feel free to shoot in questions, and I can either get your question answered in the chat or pause Jennifer and discuss the topic. And then we always like to ask if you can just shoot in your position, who you're with, anything like that. It kind of helps us in our conversation if we're, tailoring this a little more towards architects, or if we have some contractors or plans examiners on the call. That's always helpful. Thanks, Gary.
Yeah, that's okay. That's super. Yeah, it's super helpful to know that. I tend to frame things like, okay, this is the kinds of things I think an architect would want to know. So I'm always curious how many folks are architects on the call, but if most are plans examiner or energy consultants, then we can go into the weeds, but I think I'll run out of time if it's too much into the weeds. So just Grant can go, put a stop or pull me back or answer the questions, in the chat, directing people to the code section. Okay, with that, I'm gonna get going. We're gonna just start out with an energy code overview. A lot of times we do have folks that take our courses that are fairly new to the energy code, so I want to kind of give an overview first, and then some really high level changes for 2025. Then There's a mandatory measure that's impacting all occupancies. It's the service hot water heating for heat pump water heaters. If you've been on some of the other courses, some of this might be a review, but it definitely is going to come into play with multifamily, so I want to review it. And then there's some mandatory measures that are specific to multifamily. And I'm going to just touch on some of the updates for the envelope, ventilation, heat pumps, and electric ready. We'll spend some time on electric ready. And then prescriptively, which is tied in with the performance method, we're going to hit on some of the changes there for envelope, hot water, solar, and battery. And then we'll conclude the course. Just reminder, the 2025 building code is going to go into effect January 1st in 2026. So today I will show you what's in the 2022 code, but mostly, I'm going to be saying, okay, here's what to look out for 2025. And if you don't have a copy of all of the documents, there's available on the energy.ca.gov website, and then soon they'll be publishing it in its more finalized format. But right now it's still, you get it underscored and crossed out so you could see what's changed from the 2022 code. And the big pictures for 2025 with this update was really to expand the use of heat pump technology for both space and water heating, to encourage electric ready buildings, to help owners transition their buildings to all electric easily. And we're talking new construction here with the electric ready. There's some expanded PV systems and battery storage to achieve cost-effective installations. Mostly that was impacting non-res occupancies. And we're going to strengthen some of the ventilation standards in multifamily buildings, and we're going to touch on that briefly. All these documents can be found on the California Energy Commission website, which is energy.ca.gov. And this whole process is on a 3-year cycle. So every 3 years, there are stakeholders involved with coming up with the energy standards, and it's extensively reviewed, and everything that goes into the energy standards are shown to be cost effective before they're adopted and incorporated into the updated energy code. The code, a couple code cycles now where multifamily residential construction was pulled out of the non-res part of the code and this residential part of the code. So now we have 3 kind of buckets of how the energy code is organized, with 4 chapters or subchapters specifically dealing with non-residential construction. Then we have 2 subchapters specifically dealing with single family residential construction. And then we've got 3 subchapters specifically with multifamily residential construction. Today, we're just going to be talking about subchapter 10 and subchapter 11 for new construction. There really were not many changes to the additions and alterations. That's largely intact. And because we only have an hour and a half, we're not going to delve into all the nuances of additions and alterations for this particular class. And to keep in mind that the multifamily residence, it covers the dwelling units and the common use areas. And then for the non-res spaces, if you have them, then you would refer to the non-residential subchapters. The standards themselves, there's many support materials and manuals. So you've got the standards, then you've got your what's called reference appendices. We're going to hit back on that this is an important kind of document, as there's a new section in there we're going to talk about. and specifically that multifamily addresses. And then we've got our compliance manuals to help you follow how to show compliance. So if you're wanting a better handle on what's allowable, not allowable, sample questions, both the multifamily non-res compliance manual and the single family compliance manual are super useful. And then new to the 2025 standards, they've added another manual you might see out there called the Data Registry Requirements Manual, which may or may not come into play for plans examiners, but mostly that manual there is to really help the providers that set up the data registry for low-rise residential and single-family residences for HERS. We'll touch on that. There's a great resource table, 100.0A, that's in the beginning of the standards. And I like this table because it just lays out kind of your occupancy, the application, and then what is mandatory, what's prescriptive, what's performance, and where you can find that information if it's concerning an addition and alteration. So super handy. 3 broad terms before we dive into it. In case you need a review, mandatory requirements apply to everything, to all occupancies. And the performance method is the computer method. We could trade off, and the baseline for that computer energy modeling approach is the prescriptive component package, where we have requirements. Yes, they're mandatory within that prescriptive component package, but it's really like following a recipe or a checklist. So you do all of them, and that imagined building that you do all of those prescriptive components becomes the baseline for now doing an actual energy model based on climate zone. We a lot of times call it computer modeling method, performance method. And what we do with that is we compare a baseline building to the proposed design that the architect has provided to us, and then we can calculate with the aid of the software, calculate if that building is going to meet the energy budget. And that way it gives flexibility to the design team. And there's 3 metrics we look at, and it's based on time-dependent valuation. In other words, it's based on the amount of energy that the building uses and the amount of energy that went into delivering the energy to that building. And if that shows that the building passes, it means it uses less energy than the baseline, both in terms of efficiency and the total TDV, then that component passes. And then there's something called a source energy, which is basically a metric for looking at the carbon impact or the CO2 equivalent. So greenhouse gases impact on producing that energy. Now, for the 2025 code, the metric has changed. So now you're going to see something called a long-term system cost, or LSC. And it's the CEC's, or California Energy Commission's, projected present value of costs over a period of 30 years. So it's not a prediction of individual utility bills. We can do some other additional calculations to look at that. But as far as showing code compliance, it's now going to be this long-term cost, or LSC, metric, in both how efficient the building is and then the total. And the total includes your solar energy and battery if you have it contribution. The other kind of big picture is that many of us, we might be used to hearing HERS, which is a home energy rating system. And we called the folks who did these tests on the buildings during construction HERS raters. They do things like duct leakage testing, blower door and envelope leakage testing. They'll look at the exhaust fans, kitchen hood fans, the heating and cooling equipment efficiencies, capacities, etc. And then they would assist and sometimes complete what's called the LMCI or LMCV forms, part of the low-rise multifamily installation and verification forms. So under the new code coming up 2025, instead of seeing HERS rater, it's going to be an ECC rater. So the old system had everything HERS under Title 20. So not part of Title 24, but actually under Title 20. And the HERS rater did the HERS field verification and diagnostic testing. Now, under the ECC program or the Energy Code Compliance program, we have an Energy Code Compliance rater who does field verification diagnostic testing. In the code, you see it abbreviated more and more as just FV and DT. And now this part of everything to do with the HERS, now replaced by ECC, it's under Title 24. And it's also going to include more language and requirements for quality assurance, for an audit process for the ECC raters, and they can even achieve exemplary status. Okay, well, I take a quick sip of coffee here. Grant, fill in.
Yeah, sure. This change isn't going to be that significant from a actual changes to the code. Kind of the idea, the most difficult portion of this is going to be the name change, as silly as that is. And that's just going to take time. But the benefit is the switch from getting it out of Title 2020 and into Title 24. This hopefully will build some consistency and ease of navigating the code, because everything's going to be located in one spot and it's going to be more easily referenced and available for cleanup as they do code updates. But the actual scope of work for a HERS rater, now ECC, is effectively the same.
Yes, thank you so much for filling in on that. So the process for low-rise multifamily permitting. So again, this isn't taking place for high-rise or buildings with 4 habitable stories or more, just the 3 and less. Architects team does their design submittal, there's construction, and you get your final occupancy. So the LMCC compliance forms are created, uploaded to the HERS registry. And then from there, you have your LMCI installation forms that are completed, the LMCV, the verification forms are completed. Also, these forms are uploaded to the HERS registry. And then the building official can confirm that the forms are uploaded and signed. And then if all that's a go, the building can receive its occupancy permission or the final occupancy. So CHEERS is the provider organization for California Title 24 compliance right now. And they're responsible for training and certifying the HERS raters. So it's this provider information where that new data registry provider handbook is now the 7th in that series that the CEC puts out. And it's pertaining to this part of it. And now with the new code, like Grant said, we get the new name change. It's ECC Energy Code Compliance. But if you're having to flip back and forth between different versions of the code, I want you to be aware that that's what all this is about. And so currently under the 2022 code, we'd have a form, performance, computer method. We've got our time-dependent valuation. That metric will change in the new code. But if you pass the efficiency score, you pass your total score. Total includes PVs and battery and your source energy or that carbon proxy. If all of your project is, better than baseline, you pass. That gets loaded up, and we load it up to the cheers. And then what shows up for the HERS rater, which will be the ECC rater, but the HERS rater is they will see the list of forms that will be pertinent to the type of testing that they have to do on the building. And a lot of this, it could have, sometimes it has to do with the quality insulation of the envelope and the mechanical system meeting certain efficiencies. But this is supposed to add a layer of quality control on all our buildings. The mandatory measures that impact all occupancies are fairly extensive. Well, let's say they are now under the 2025 code becoming more robust. That's a better way to put it. And also under this sort of, in the new part of the code, there is a lot of new definitions. So the CEC has gone out of its way to really define certain types of equipment and certain occupancy types that it's going to be using throughout the code. And just as example, we're going to touch on what is now coming into play for heat pump water heating systems. So the heat pump water heater systems, first they're defining it. And just to be clear that you can have a heat pump water heater that is integrated, which means that the heat pump condenser compressor unit sits on top of the tank or in front of the tank, but it's all one appliance. And then the pictures on the right-hand side there, all the rest of those pictures are examples of split systems. But now to just be more clear, the CEC has defined a split refrigerant system where refrigerant is run between the outdoor unit compressor condenser and to the tank of what'll be hot water. And then there's the split hydronic system. And that's differentiated because instead of running refrigerant between a tank and an outdoor unit, you're running water instead, so that all the refrigerant itself is contained within the outdoor unit. And then there's multi-pass and single pass, meaning does the water or the refrigerant just go through the system once or multiple times during that heating cycle? So this is an example of a hydronic heat pump water heating system. Currently, the Sandon system is one of the only ones available that's hydronic. And so we've got insulated water lines that connect the outdoor compressor condenser units to the storage tanks. And those storage tanks are single pass type. And this is what it looks like, and it's popular now. And the benefit of something like this is that there's a very small amount of refrigerant in the whole system. And this one also just happens to use CO2 as the refrigerant. So it has a global warming potential of 1. So under those mandatory measures for all occupancies, there's been some updates on space conditioning equipment, the service water heating, pool spa equipment. Kind of the big takeaway is that they're trying to include more easy to follow mandatory measures to kind of clean up the code for what we were seeing as maybe being installations that weren't up to par to really achieve the energy efficiency that our state wants to achieve. Today, we're just going to look at the service water heating as an example. And then under that service water heating category, as an example, there's all kinds of things to take a look at in terms of temperature controls and the insulation and recirculation loops and isolation valves, etc. But there's a brand new section specifically for air source heat pump water heaters, section 7. And when we take a look at that section, now we are delving into some of the requirements, and I put the text here for you because this, you can go back, you're going to get a copy of the slides, you can review it, and it was just here to be convenient when you get a copy of the slides. But kind of one of the main things, first off, is they say, well, you have to make sure your system does have some backup heat because there is operating parameters for heat pumps in terms of temperature control. And you also need a certain amount of ventilation for that heat pump to operate because that heat pump, it depends on the ambient air temperature to extract heat out of that air and to put it into your tank of hot water. And if you install it without ducts, then there's certain minimums you need to meet based on the size of the compressor. And just kind of as a rule of thumb, you can use, if you don't know what kind of heat pump you're going to be putting in, but architect, you can take a look at this and use 4,200 BTU hour compressor capacity. It's really a common size, and then you would use that compressor capacity and multiply it times either the 25 square inches per kBTU for your net free ventilation area, or 100 cubic feet times that number for the volume of ventilation that you need. Gets a little nuanced, and so they also define the net free area. But this part is it's in the definitions part of the code. So I put it here and did a sketch for you all to hopefully make it a little easier to understand what they're looking for that net free area. But what it really comes down to is that we were seeing a lot of, like, the royal we, but I mean, Grant and I've seen it, and many people that were consulting to the California Energy Commission were seeing it, that there really isn't anything wrong with the heat pump water heater technology, but there are a handful of things people needed to do to make the installation energy efficient in order to, basically not give heat pump water heaters a bad name because of poor installation. Because ultimately, a lot of us, when we're in the services industry, we want the homeowners and the clients to be happy. And then from the code enforcement side, it was really hard to know what are you supposed to be looking at, and there really wasn't much in the code that you could say, hey, this thing isn't installed properly. So the idea now is that they give you some more requirements so that you can reinforce good installation. And so with ducts, then the big thing here is that, you're going to be looking at the penetrations with the ducts being sealed. But because of this too, you need to make sure the duct diameter is of a certain size, or that the net free area of that duct itself either meets the manufacturer's specification, or, you know, you're going to have 20 square inches, for example. And that's with if you're going to have an exhaust duct only. So you can have a supply only, an exhaust only duct, or you can have a supply and a return or exhaust duct. And if you do that, then the code now is explicit in saying that the airflow from the termination point shall be diverted away from each other. So they're just putting what was common sense stuff in many ways into the code to now have something that people can look at. Also kind of works as a checklist. So that section is applicable to all occupancy types, you know, multifamily, single family, and non-res. Okay, now any questions before we move on to some of the mandatory measures specific to multifamily?
Nothing's come through yet. Yeah, just to kind of wrap up that last section. I'm referencing clients and architects currently to those upcoming code sections, because that heat pump installation, having a design that accommodates it, it just needs to happen sooner in the design process. So having that code language now is still really useful. We did have a question just come through. Steve asks, why do we insulate the exhaust duct on the heat pump water heater?
The reason for that, the thinking is that that air inside the space, the closet, a lot of times it's communicating with the house or the apartment. Like in that example, it was from an apartment, and the exhaust air is very, very cold, and they just want that to go outside, and just to stop some of the heat transfer of that really cold air through the duct into the closet, which communicates with the rest of the space. So that's one of the reasons. So both ducts are insulated.
Great.
With the multifamily section, just as a reminder, this part of the code, we're really talking about new construction, but the additions and alterations section in 180.0, and then all the subsections after that, it references back to these mandatory measures a lot. But otherwise, for today, we're mostly talking about new construction when it comes to these mandatory measures. And these mandatory measures under the multifamily section specifically are applying to the dwelling units and the common use areas in a multifamily building. And then the non-residential occupancies would comply with the sections 120 through 141, which were those those 4 sub-chapters specifically for the non-res and hotel motel occupancy types. Today, we're gonna focus mostly on some building envelope changes for the 2025 code, on some ventilation and indoor air quality, a little bit on some space conditioning systems, and again, the water heating systems. There's just a lot in the code that was dealing with water heating systems this time around. So it's kind of a theme going on when you look at what has changed in the code. And then that also kind of sets up for electric ready buildings, which also touches on water heating. There is, in case we have any electrical engineers or folks who are doing the plans examining, there is a little bit of change on lighting, and it mostly, and we're not going to touch on it in any detail. I just kind of a FYI or heads up if you didn't know the Taylor method for lighting is going away, but there's more flexibility in different subcategories now in the category area method. So it's not big changes, but potentially how you calculate it could be different. So just kind of heads up there. With the envelope, there still is, for windows as part of the envelope, there's U factor of 0.58 continues to be the maximum U factor allowable. That hasn't changed. There's some exceptions to that has to do with a small amount of like a 0.5% conditioned floor area. Equivalent to that can be windows that exceed it. Your 30 square feet of garden windows can exceed it, but the big change, quote unquote change, is that there's this new exception to fenestration installed in buildings that meet Part 7 of the California Building Code. And for those of you who really pay attention to the code, that might sound odd because for years and years and years, Part 7 was vacant. But now with California and wildfires, we have a California Wildland Urban Interface Code, and that is occupying the Part 7. So just kind of FYI heads up. So now the energy code is reinforcing what's going to be coming up, what you'll be learning about in Part 7 of Title 24 for wildland urban face areas, or wildland urban interface areas, sorry. And the exception basically is that you don't have to meet that mandatory minimum on the U factor. Also new in the, it's kind of interesting, new on the envelope, they did add a new section specifically for slab edge insulation. So if you want to know more about it, I found that Owens Corning on their website, they put out a good technical bulletin just talking about how ASTM C272 test method is done. And it's basic, this new section is just clarifying that if you use insulation on the slab of your building, that insulation has to be of a type that is not going to absorb water. For the ventilation and indoor air quality, this section has changed a little bit, but the big picture is that the indoor air quality, so how much fresh outside air we get into a building, it addresses both the residential and the non-kind of residential occupancies. And in this part of the code, it does keep referencing you back to residential code and HERS verification, which would be ECC for the residential, for the dwelling units. And then for the dwelling units that are, for the spaces that are not dwelling units, then it's going to reference you back to parts of the non-residential code and ventilation and those parts of it. So kind of a reminder, it's not applicable to townhouses or dwellings. So 2 dwelling units, it's totally residential. But otherwise, if they're attached dwelling units, then you're going to kind of be back and forth between, well, is this a residential occupancy type, or is it the non-residential occupancy type? And you'll have the different formulas. But nonetheless, the indoor air quality still is dependent on ASHRAE for 62.2 as the basis for the residential, and ASHRAE 62.1 for the non-residential occupancy. So formula hasn't changed here. I put this in for the architects just because you can use this as a good estimate. for how much ventilation requirement is needed for an individual dwelling unit or apartment in multifamily. And the reason for that is we're seeing more and more architects kind of planning their ventilation strategies as part of their design. Because as the space heating moves more and more towards heat pumps that are not using outside air through the heating and cooling system, you need a separate system that is bringing in the outside air. And that separate system can be a balance system, it can be an exhaust only system, and that balance or a supply only system. And that balance system can have heat recovery or energy recovery. And also, we are going to have mechanical exhaust in the kitchens and bathrooms. So what we see a lot in the current practice many times is to have that local required exhaust from your bathroom, exhaust only, run continuously and double as your fan system for bringing in your outside air. But the problem is it depends on a really leaky envelope. It depends on negatively pressurizing the inside of the house or the apartment and then pulling air into the dwelling to make up that air so the fan can exhaust it. And the same thing, can happen with your kitchen fan. So what we're seeing more and more is that as the builder builds the dwelling units tighter, they're looking at using balanced ventilation to mitigate for having air leak basically from the outdoors, but also between apartments. And then side note, all of these systems, yes, it comes up, people ask about fires. And so, yes, these systems need to be able to be switched off for poor outdoor air quality and, labeled as such. Not everyone we're finding out is familiar with the energy or heat recovery ventilation system. So I'll show you a few pictures of that. But basically, it's a box that holds a core that's called the ERV or HRV core and filters and a couple of fan motors. And you pull fresh outside air into the box through a duct, and it goes through that core heat exchanger and transfers some of that heat to the outgoing exhaust air that's being pushed out of the building, thereby tempering the supply air that's introduced into the apartment. Now, currently, with multifamily, there is a requirement or there's a way to kind of mitigate or get out of doing blower door or compartmentalization testing that requires a HERS rater to come out and test these buildings. In lieu of doing all that testing, you could install a balanced ventilation system. And that got the builder and the HERS rater out of doing that testing. Okay, that's going to change in 2025, but that's currently how we have it. If you do an exhaust only fan system, then you're going to do the blower door testing, extra testing. So when the HERS rater comes out, they're going to be looking at a couple of things. They're going to be looking at the mechanical ventilation for the bathrooms and the kitchens. And the forms are really similar to single family, but there are some big differences because they're supposed to check for backdraft dampers and air sealing to stop air movement between the dwelling units. But for the most part, it's really similar to the single family. If you do install a HRV or ERV, then there's additional forms and additional things they look at. And the pictures on the right just shows an example of a Zender brand. There's a lot of brands out there. This is maybe the most expensive brand, but it was the one chosen for this particular project. And small 3-inch ducts are run throughout the space to provide that fresh air and then to exhaust the quote unquote stale air through the heat exchanger, and thereby allowing the occupants to have tempered fresh air in their space. And it operates continuously. Okay, for the high-rise dwelling units, even though we don't have a HERS registry, the HERS or acceptance testing technician, ATT, is to come out and also look at the fan function for continuous outside air and your bathroom and kitchen exhaust. And I put these forms in here as an example and kind of give you an idea of what they look like. But mostly what I'm seeing is that if you're an architect, the forms are handy to look at because it gives you kind of a checklist of things that you might want to include in your drawings, or at least give you a better idea of what you're looking at. We're also finding that for some of our multifamily, well, even for some of our single family projects, a lot of the early design work, the architects are looking to their energy consultant to give them some idea of what's going to be required for the ventilation system before they have their mechanical engineer on board designing the whole thing. Grant can probably talk to you more about that. He's intimately involved with that process where the architects need to know, but the mechanical engineers aren't engineering the whole system yet. Yeah, feel free to jump in, or if there's any questions about that. Yeah,
you're right. It's just a gap in timing that we've seen a lot.
Yeah. And then for the 2025 update, so mechanical IAQ ventilation, you can have outside air, balanced ventilation, or supply only ventilation. And now the compartmentalization testing, which will be done by the ECC rater. So it might note what's missing off the list is the exhaust only. So that's no longer a valid option in new construction. So you are going to be doing a balanced ventilation or supply only ventilation. And so even though those forms were for the 2022 code, those HERS forms still have a lot of the same good information on them that you might be interested in. Also, now the code's giving you more information on that. Now, if you're doing additions or you're doing alterations, you can still do an exhaust only IAQ ventilation fan. But there's some caveats with the alterations. It depends on what you're doing. So with the code now, it reads for the balanced ventilation. This is the new part of it for the IAQ. So balanced supply ventilation component accessibility. So both balanced and supply, not exhaust only. And all the parts and pieces need to be accessible. So mostly we're talking about the air filters and the HRV or the ERV energy or heating recovery cores, and they need to be accessible from within the occupiable space or a basement, a garage, a balcony's okay, mechanical closets, accessible rooftops are okay. They also need to have their access panels located no more than 10 feet above a walking surface. There is an exception, and that's if you put it in an attic. You can, but there's some additional requirements, and that you need a fault indicator display. You have to have an access door that's located in a wall or through a ceiling, but that access hatch would include an integral ladder. And then you need a walkway from that access door to the HRV, ERV. So you could use it in an attic, but it has to be accessible, is the main thing. And so why is because there are things you need to do for these systems to maintain them. So example on the right was a hallway closet installation. And so you can open the closet door, and then you can open the panel to access the ERV core and the filters. A lot of the systems now are coming up with the fault diagnostics, and they have their fault indicator display so that you would mount that display so that it would alert you and warn you, and you could see it if something is not functioning properly. And also it reminds you when it's time to change air filters or do maintenance on the ERV core. For the common use area, the ventilation formula is different. A lot of times this is where, okay, you're going to be working with your mechanical engineer at this point anyway. So for anybody who's on the call that looks a little bit more on that side of things, I just want to give you a heads up that the formulas have been updated. I mean, when you look at the formula itself, it seems mostly the same, but what's changed is the table. So in essence, it changed the formula, even though mathematically it looks very similar. So there's a brand new table, 60.2b, that has minimum occupant load density and the ventilation rates. So in this case, I gave you the formula, and then I'll give you an example. So if we look at corridors, it has a minimum occupant density load of 5 people per 1,000 square feet. And then it gives you your area-based minimum ventilation rate, which really has not changed much from the 2022 code. So for the most part, your answers are going to be very similar to what you had in the 2022 code anyway. But example, if you had a 2,000 square foot residential common corridor, you would do the first part of the formula and plug in your 5 per 1,000 square feet. You end up with 150 CFM, or you do the second part of the formula and it's the 0.15 CFM per square feet, but you have 2,000 square feet of it. So 300 CFM, and then you pick the larger of the two, and then you can pick your ventilation system to meet the 300 CFM requirement. For the individual, back to the individual dwelling unit, space conditioning, they're wanting to give more clarification on heat pumps since they're becoming more and more popular. So, for example, if you're in climate zones 2, 3, 4, 5, you're gonna be, which is, 4 and 5 is San Luis Obispo County and the northern part of Santa Barbara County. If you're going to have a heat pump that has a defrost cycle on it, then it's spelled out that you're supposed to have a delay timer set on it, no greater than 90 minutes. And for the heat pumps that have third-party thermostats, we're finding that there's this capacity variation. So they call it heat pump or capacity variation with third-party thermostats. Basically, what they're saying is your conditioning system and the thermostat together shall be capable of responding to the heating and cooling loads by modulating the system compressor speed. So again, this is a mandatory requirement. So your, mechanical engineer who's specifying this equipment, they should really be considering what's going on with the thermostat that is being chosen to go with this equipment so it meets this new requirement. Okay, for the mandatory measures under that hot water, there's a new section, or really an elaborated section specifically for hot water piping insulation. And for example, the first 8 feet of the inlet cold water piping is also supposed to be insulated, even though we're dealing with the hot water piping. In addition to all of the hot water piping and aperturances needs to be continuous. There's clarification to explicitly say that the supports, hangers, and pipe clamps shall be on the outside of the rigid insulation. That the pipe insulation seams need to be sealed. That the pipe elbows and the T's need to be mitered or preformed or site fabricated with PVC covers, and that even the isolation valves need to have extended stems to allow the insulation around. And then it keeps going from here. This is just an excerpt. And the reason this is now under mandatory measures so explicitly for multifamily projects is because we've seen, and the CECs continue to see, that for these heat pump water heaters, yes, a lot of the pipes are insulated, but there's been there's a lot of room for improvement. And so this is just an example of a project I was on. I took a picture of it, and I could see where some insulation is missing, but then also, for example, the clamps that hold the piping in place, the insulation stopped. The corners aren't really adhered. The insulation starts to break, and when you bend it, et cetera, et cetera. The reason this is important is because the heat pump water heaters, it's been shown that if the pipes are really well insulated, it really helps keep the hot water hot in your tank, and it helps to make sure that your hot water is delivered to the fixtures, and it improves that recovery time of the heat pump water heater appliance. So it's now just required, and it's also, as a plans or someone who's in the field, you're now going to have a list where you can actually go, yep, do this, check this, and look at this, if that's what your department chooses to focus on. But it is a code requirement, or will be in 2025. So when it comes to electric ready, what that means in the code is that you can install gas appliances, but it recognizes that the California Energy Commission recognizes that California is heading towards all electric for new construction where it's feasible and where it's economical. And that's a way to help reduce our pollution and bad air quality, because we still produce a certain amount of our hot water heating, space heating, by burning fossil fuels. So we're trying to not burn so many fossil fuels as we have more and more electric generation that is from renewable resources. So we're at a tipping point where California can have cleaner energy by going all electric. So if you install a gas water heater, that's still allowable, but you have to make sure you have the electric ready set up for a future heat pump water heater. Same thing with furnace for space heating, needs to be set up for a heat pump water heater. Cooktops needs set up for electric. Dryers, both in the dwelling units and the common space, it can be gas, needs to be set up for the electrical connection and conduit and outlets for electric. That is the each one of those topics goes more, there's more information and in-depth and requirements, but really it only comes into play if you know that you're going to use a gas appliance for any one of those functions. On the multifamily projects, a lot of our clients have been looking for Energy Star, moving all electric anyway, but the California Energy Commission has fielded a number of questions about the electric ready for the common space dryers. They want to put in gas dryers. That's what everyone's used to. And then now they need the requirements. So good resource is the blueprint, and it spells out all the electric ready requirements for your closed dryer. So I recommend this to review if you know that that's coming up for you. Under the 2025 code, the electric ready building section, they've pulled that requirement. They pulled that specifically having to do with the hot water. They've pulled it into the electric ready section, 160.9. So when you get the new code, those parts aren't going to be with the hot water anymore. It's going to be with the electric ready section of the code. And along with this, there's a new appendix, J15. And it specifically talks about the qualification requirements for a central heat pump water heater. And that section is new. And then there's clarifying language now for Section A, general requirements, just reminding folks that your electrical engineer has to, based on these electric ready requirements, they have to have sufficient capacity to supply the full rated amperage for each of these electric ready appliances per the electric code. That includes the main service conduit, the electrical systems to the point, where is specified in the drawings for each of these electric ready requirements and any on-site distribution transformers. But again, this only comes into play if you're installing gas appliances. And really where we've only been seeing it mostly is in the central heat pump water heater ready section. What we're seeing is that some of our multifamily projects, even though the whole bulk of the building may be electric, engineers oftentimes are still specifying gas boilers or other type of on-demand gas water heating central systems. And so this is where this new section comes into play and clarification that now central system will have to be electric ready. And then kind of back to the individual dwelling unit level. If you do individual dwelling unit gas water heaters, then part of the electric ready requirement is to designate a 39-inch by 39-inch by 96-inch tall future heat pump water heater space, and you need to install the condensate drain. So you can install a gas unit, but you need to have that drain and ready to go and be there for when it was, in addition to the electrical requirements for the future installation of a heat pump water heater. So back kind of the central heat pump water heater system. So gas water heating is allowed, but now to be electric ready, you're going to have to allocate the physical space for those heat pump water heaters in the tanks. You need to provide for the ventilation path or pathway and strategies, depending on the type of system. You need to provide those condensate drain piping and receptacles, and then you need to reserve that physical space and the electrical power for the electrical system. And then this code section, it goes into more detail on each of those topics, but it also says, you know, you would provide this ventilation pathway to do XYZ per reference appendices JA15, blah, blah, blah. So it keeps referencing the joint appendices 15, that new section. Because of that, and because not everyone has the reference appendices super handy, I included that for you just to get an idea of what that looks like. And it really does, it's laid out fairly simply. The requirements are based on the size of the gas water heater that's being installed. And it's really, if it's less than a 200 kBTU hour unit or more than or equal to the 200 kBTU hour. And then each of these requirement solutions are based on a factor of 10 kBTU hour of installed capacity. So the cutoff there is basically like, okay, if it's like a small system or a larger system. And the space heating requirements, for example, it's going to be based on 2 square feet per 10,000 BTU per hour of your heating system, and it gives you a minimum lineal dimension of 48 inches. But for the bigger system, that's going to bump up to 3.6 square feet per 10 kBTU hour of your installed system. And you have to have a minimum lineal dimension of 84 inches. So, and that's supposed to be designated on the plans, but this appendice J15 kind of really spells out what you should be seeing on the plans, the drawings for what the engineers and the architects have assigned for the space to be electric ready if they've chosen to install a gas boiler central heating system. And there's similar requirements for the storage tank space in the sense that, again, based on whether it's less than the 200 kBTU or greater than the 200 kBTU hour, then that would determine how many square feet per 10,000 BTU of capacity that you would have just reserved for the tanks. And then ventilation requirements kind of follows that similar pattern. If it's, you know, more than or less than the 200 kBTU, it's going to determine based on 10,000 BTU per hour capacity of installed gas unit capacity, a multiplier of like 70 CFM for the smaller requirements or 420 CFM per 10,000 BTU for the larger requirements. And then it goes on from there with the condensate drain piping requirement based on, you know, the tons of refrigeration capacity that you would be able to drain, again, based on whether it's bigger or smaller than the 200 kBTU hour capacity. And then the electrical requirements that follows a similar pattern. If it's less than, more than the 200 kBTU, and again, then the KVA requirements and the for both the heat pump and the temperature maintenance tank, sometimes called a loop tank, or recirc tank, then that's also based on those same requirements. But this is kind of gets into the meat of what is supposed to be designed for. So that's there for your reference. And then I'm going to quickly move along for kind of the update on some of the prescriptive changes. And so the good news here is really not a lot has changed. All the big changes are everything that we covered for multifamily. And this is just has some minor updates. Significant in a way, but much minor. So there's a couple things on the building envelope and a little bit on space conditioning ventilation systems. We won't really be able to get into all the details on ventilation systems. So if you're a mechanical engineer, you just want to go and delve into that whole section. The water heating systems, really, it's referencing back to everything we just went over for our water heating. And then there's been a little bit of change on how we calculate the photovoltaics, but it's to make it more simple, and it's to make it more applicable to different climate zones. So roof ceiling insulation, just as a reminder, option B is an attic with ducts in the attic. Option C is an attic with ducts in the conditioned space, and option D is a non-attic roof or cathedral ceiling. So basically there's hardly any changes for the option B and C, but there was some change for option D. So kind of the main takeaway is that when you have a cathedral ceiling or non-attic roof for climate zones 2, 4, 6, 7, 8, and 12, now a low sloped roof has some cool roof requirements. And that's basically it. Now we're done with envelope, except for the windows. So not a whole lot's changed there. And then on the window performance values, there are some updates. I think they basically tried to simplify the table, and this is just an excerpt of a curtain wall where they've eliminated the differentiation between 3-story and fewer habitable stories or 4 or more habitable stories. And they basically took out the 4 or more habitable story requirements. So you can see that there's, the old code's got a line through each of those. And they basically rolled in all the requirements to what was the low rise requirements. And then for curtain wall, there's basically no changes in that sense, except that now, like if you were high rise in climate zone 1, you would have had a solar heat gain coefficient value, and now you don't have one. So it's not really a kind of a big change there. And then for your other windows, there was really only a change for climate zone 1, 3, 4, 5. So our, San Luis Obispo County, Santa Barbara County zones, and then 11 and 13 through 16, the U factor changed, it dropped, it decreased to a 0.28. But all the other climate zones had no change for their U factors and no change for their solar heat gain coefficient. So pretty straightforward. Space conditioning, dwelling units only. I mentioned this, prescriptive requirements, no change. It just as a reminder that this is used as the baseline. And for most of our projects in the climate zones we work in the Tri-County region, our baseline was a heat pump for both 3-story or less and 4+ stories. So, okay, no change there. This is just example of, tying back to the HERS change. And a lot of times we're working with folks on the multifamily projects who are looking for performance credit. And one way to get a performance credit for the multifamily projects is to look at low leakage ducts in conditioned space. And that would bring in the HERS rater, but it will be an ECC rater, or it could be an ATT rater or ATT technician, that looks at that. So want to bring that up. Also, the forms give you, the information that sometimes you need to put on your drawings or notes if you go that route. Also, what comes up a lot for us is a variable capacity heat pump compliance credit. And what this means, in this case, I said triggered on the CF1R, but really it'd be triggered on the low-rise multifamily MEC 33. On your, that'll be the form you use, but it'll be triggered on your low-rise multifamily form you turn in. So sorry about the typo on that, but the credit works the same way, essentially, for the residential single-family occupancies. So the unit itself, the indoor unit, needs to be within the air and thermal boundary. So how that can look if you're doing a ceiling recess is to either put the insulation up at the top of your attic space and have potentially an unvented attic. Or if you have a vented attic, you can create a box that goes over and around that recessed ductless unit. And you can tape and seal that drywall box and have it be a continuous air barrier with the drywall ceiling and drywall walls. And this is a credit that comes up. I just the other day got a phone call from the HERS rater and the mechanical engineer saying, something changed during construction. We need that credit now, and so it's a good one to have. But the architect, so kind of go back, but the architect is so much easier if the architect is on board with already taking this credit if you need it, so that you can detail your drawings and call out the continuous air barrier. There's been some updates now on the balanced ventilation. There's a whole section on DOAS, dedicated outside air systems. I'm going to just direct the mechanical engineers to that. But if we're looking at the smaller systems, that is an ERV, HRV, for the individual dwelling units, kind of the biggest update here is that, yes, it is as part of the current code, and there's fan efficacy requirements, and there's recovery efficiency requirements. And really what is changing is that the climate zones each of these requirements applies to has been updated, and that all the HRV, ERV systems serving those individual dwelling units shall have that fault indicator display that we had talked about earlier, and that the FID, or the fault indicator display certification or installation, shall be verified by an ECC rater. So there's some increased work for the HERS raters coming up in the code, but not much. Okay, for the hot water, the baseline, you basically, individual unit, currently you can have a heat pump, you can have a gas or propane instantaneous. And for your central systems, you can already design it with the heat pump central system, or you could go with the gas and the propane central system. So prescriptively, really, there's just been revised language and some minor updates to clarify this. However, So currently the heat pump water heaters, and there's a new clarification that if you have a dwelling unit with just one bedroom or less, you can use 120 volt heat pump water heater instead of the 240 volt requirement. Currently, you can use a gas on demand system prescriptively, but under the 2025 code, that option's only going to be allowed for buildings with 4 habitable stories or greater. Otherwise, you have to use the performance method and try and trade off. So really kind of moving everything towards heat pumps. There's design considerations with the heat pumps we alluded to. This is a lot of good rules of thumb that I like to remind the designers where they're looking at locating these heat pumps. However, now with those with those mandatory measures, a lot of these things, these requirements are baked in, other than understanding that the noise is typically around 45 to 50 decibels. So how you design for it in a small apartment can be important. So a lot of times we'll see them on exterior closets where the closet's open to a balcony, and then that closet has a buffer. That way the closet's exterior to the dwelling to help cut down on noise, etc. So yes, you could still install your gas system prescriptively, but under the new 2025 code, there is some explicit language about prescriptively having a mechanical or digital thermostatic master mixing valve on each distribution. So kind of in the weeds there, but the idea is, yeah, you can still do the gas. You're supposed to have a solar savings fraction or some solar thermal component, but you can use the performance method and trade that off, which is really common. And then, yes, you can have a central domestic hot water heating system that is the heat pump system. And then prescriptively, there's requirements for it. And we used to have a requirement. Currently, it says if you have a single pass primary heat pump water heater, then the primary thermal storage tank shall be plumbed in series if multiple tanks are used. Okay, but that whole thing goes away. And now the new code just says the primary heat pump water heater shall be a single pass heat pump water heater. End of story, prescriptively. If you do something else, performance method, you can. And then again, that thermostatic, electric or digital or mechanical thermostatic mixing valve. And then this is just an example of what these split system, hydronic, heat pump central systems look like.
We had two quick questions that came through on that last section, Jennifer.
Yeah.
One was just clarification. George was asking if when we were talking about the 120 volt heat pump water heater, a 4-bedroom home cannot use a 120 volt heat pump water heater. That was his
not
takeaway.
Prescriptively. Yeah, so the prescriptive is like you follow the recipe checklist, just follow the recipe. So if they really want 120 volt, then you can put, performance method, but that's just prescriptively.
Right. The second one was asking how the code update addresses racks of gas instantaneous hot water heaters, like a daisy chaining them for like a central domestic hot water system.
Prescriptively, you can still do that. I'm not exactly sure the question, but there's these mandatory measures you have to comply with for a gas or propane central system. So you follow those requirements. And then if you're trying to do the prescriptive, then you're kind of locked into it. But you can always do the performance method.
Right.
And
So
have that. set up.
So it's still a viable route. I think something just the overall is these prescriptive requirements. Not many projects for new construction on average use prescriptive compliance. But when we talk about those performance methods, you're being compared against it. So it's setting your baseline, which is why we often focus on what these requirements are, because it's what we're compared against. David followed up and said, it's unclear how to model these properly. Looking for
Yeah.
performance guidance with a mind for the code change. So unclear on how to model the daisy chained instant gas to create a central system.
Yeah. Okay. That one, I think let's go into Code Coach, or we'll hang on to the end, because really we only have a few minutes and I want to
Okay.
hit on the solar and battery, but I mean,
Yeah.
we can help
Okay.
you. Yeah, we can
We'll
help you.
connect with you, David, and get that discussed. George is still asking about when can we install / remodel for the existing code? So he's only worried about 2022, the 120 volt. So I guess maybe just rehash when they can use a 120 volt under the 2022 code.
Oh, I mean, there is an exception for in the single family residence, where you have like ADU that's 500 square feet or less, or an addition 500 square feet or less. But multifamily now, it's in the new 2025 code explicitly, where they're saying where you can use the 120 volt. But we'll have to, I mean, 100, yeah, we'll have to look it up, maybe go into more detail with the code coach or one of you guys.
See if you can finish the rest of this.
Okay.
Thanks.
The solar PV battery storage systems, basically there's two buckets of requirements, and it's really the low rise multifamily and high rise multifamily, two different requirements. But the battery ready, when you hear about that, that's single family occupancy, just kind of put it out there. And then the battery is optional for the low rise, and you could get a credit for it, but it's required on the high rise. There's Sarah, it's the area that's capable of supporting the PV system and gets 70% annual solar access. Okay. The formula currently is based on conditioned floor area and the number of bedrooms for the low rise dwelling units. The change for 2025 is that there's a SARA now for 14 watts per square foot for low sloped, or 18 watts per square foot times the SARA for steep sloped roofs. So that's something to keep in mind. The other change is that if you had a PV system size less than 1.8 kilowatts DC, you could be exempt, but they've upped that to the 4 kilowatt DC for the 2025 code update, which is consistent with the high rise. Okay. So now when we go, and back up, there's tables for factor A's for your climate zone factor and B for your dwelling adjustment factor. And I put this table here for your reference so you could have it together. And we often recommend architects use these to get an idea of how much PV they need. But for calculating the SARA itself, a lot of times you're needing to work with a PV consultant. For the high rise, the formula, it's more simple. They already had a SARA PV system size kind of exemption, which was 14 watts. per square foot times the Sarah. But now they've upped that to that's applicable for the low sloped roofs. And then also they have the 18 watts per square foot times the Sarah for the steep sloped roofs. Fairly straightforward in that sense. And here are the factors and tables for that 2022 code. Now, for the 2025 code, we have a new table and a greater breakdown of building occupancy types. And it's now broken out by climate zone. So use one table for, the old code, use this table for the new code coming up to give you an idea of how much PV you'll be required to have. For battery storage, this just applies to the 4 stories or more. And this was the energy capacity formula, power capacity formula. You had a factor B and a factor C, and you had a D, which is the single discharge rate. We can help you figuring out this formula, but this was just to give folks an idea of how much battery capacity they need. Under the new 2025 code, the formulas changed. There's a different table that goes with it. And so now you'll look at a rated energy capacity and a Sarah adjusted rated energy capacity if you're doing the Sarah method, and then a rated power capacity where the formula is much more simplified. And then we have a new set of tables for those new factors, again, laid out by climate zone and by the building occupancy types. And we still have, pardon me, we still have the exceptions. If your PV system size installed is less than 15% of that size determined in the PV equation, or if the system requirements for that battery are less than 10 kWh rated usable capacity. And we can, with that, we can help you figure out your code coach questions, and we can help you with those crunching those numbers if you need it on your PV and battery as part of the code coach service. Please give us a call, and I'm going to hand it over to Danica to tell us a little bit more about multifamily home energy savings and upcoming courses. And sorry, we are running just a couple minutes over, but we had some great questions. And as long as it's okay with Danica, we'll stay on the line to finish answering your questions.
Yeah, I will definitely make this quick so the questions can be addressed at the end. And as we wrap up, I've launched our survey. Please let us know your thoughts and what other improvements and courses we should offer in the future. And also, since today's topic is on multifamily, this slide is just a reminder that 3C Rent has a multifamily home energy savings program, which is an incentive program for doing energy upgrades. And if you have any questions on this program, the best email to reach out to is multifamily@3c-ren.org. Next slide, please. If you have any questions in receiving your AIA or ICC units, please reach out to my email, which is listed on the slide. And in the next couple of days, you will receive an email with a slide deck and a link to the recording. This is the last topic on the Energy Code implementation series, but you can access the recordings of the previous topics on our on-demand page, and I also shared the link on the chat earlier during the presentation. And I'd also like to invite everyone to our other upcoming courses. We have a webinar on QII on the 29th and an in-person course on passive solar on August 12th, and that's actually with Inbounds Green Consulting as well, and a CalGreen webinar on on the August 13th. And additionally, I did not get to add this on the slides, but I'd also like to let you know that 3C Run offers EPA 608 and HERS Rater certification training in partnership with Consul at no cost to those in our region and for those who do not receive SoCal Gas service. You can sign up for these trainings and see more offered on our website at 3c-ren.org. And with that, I'll pass it back to Jennifer and Grant to address the questions.
Thanks, Danica. Okay, so Jennifer, I think if we go back, there was a clarification request on the PV panels, the not being allowed facing between 270 and 90.
Oh, yes,
So I think it was just a clarification that this is for steep slope roofs and not low sloped.
correct.
Okay. And then Julie asked if that low steep slope multipliers, is that relevant to single family?
No,
And then she also asked if the 1.8 kW exemption for single family is still going to exist in 2025.
yes.
Easy enough. If anyone else has questions, shoot them in real quick. There was one at the beginning of the presentation that was pretty general. George was asking about coordination between other state standards. Do you know of anything that's going on of Oregon, Washington talking to California? I know they do, but it's not
Well,
like a concerted effort that I hear about often.
right. I mean, there's been a big effort to have more states all be on board with the ICC code, the international code, and then California kind of leads the way on a lot of the energy code.
Yeah.
And Cal Green.
Yeah.
And then, but within our codes, within Title 24, they're getting greater alignment with the energy code, Cal Green, now the new fire code, etc.
Yeah.
So I know, and the mechanical code, electrical code. So I know they're trying to get greater alliance that way and cross-referencing.
Okay.
So yeah.
If George and David are still here, send your question in to the code coach on the forum. One was the 120 volt. We're happy to talk through what those requirements are applicable for the project. And then David, the modeling stuff, I'm happy to help you out. Just send it in so I have a record of it.
Thank you.
Yes.
Great. With no other questions, I think we're good today.
Thank you,
Okay,
everyone.
thanks, everybody.
I'll go ahead and end the meeting. Thank you.
Thank you.